What is up, guys? Fahir here from AwesomeTuts.com, and finally the time has come that we are gonna code in this tutorial series. I know you're excited, like, whoa, honey, the dude from the internet said we're gonna code. Let's go, grab my computer and bring me my beer. Yeah, I know that you're gonna do that. So anyways, right click, create a new folder, scripts. This is the name of the folder. And inside of that folder, right click and create another folder. And this one is gonna be players. So player scripts or robot scripts or however you wanna call them, I don't care. And inside of here, right click and create another folder. And I'm just kidding, of course, we are gonna create a new C# script, which is gonna be robot or player script. We need to attach it on the robot parent game object. So drag and drop it right here. So this one, robot, this dude right here, drag and drop it on him. Double click it, open it in MonoDevelop and wait for it to load. And voila, here we are. So I'm gonna tag it quickly as a class here at the bottom and give a little bit space. So now, as always, you know that we need a couple of variables to work with in order to, well, determine all of the behavior in the class. But before that, we also need to create a public enum, which is, or actually it can be simply enum, not public, it can be private, and I'm gonna call it direction. And it is gonna determine the direction of our game object. So we're gonna have left and we're gonna have right, meaning that we can move left and we can move right. And I talked about enums. I believe that I have the tutorials talking about enumerations, what they are, for what we can use them. Basically, we just create them by typing enum, giving a name, and then open close curly brackets. Inside of here, we type names, and we type whatever we want to type. So I can type whatever I wanna type. And this is totally legit. After we want to use them, we simply declare them. So we type, for example, I don't know, direction E is equal to direction dot left. And this variable E now contains this value. And we can do something like if E is equal to direction dot left. So if the value that's inside of this variable is equal to the direction left, move the player left. If not, then move him right. By the way, I forgot, if you want to learn 3D game development, go here, grab the course, go crazy with it. You will love it. You will enjoy it. You will mention me in your prayers every night after you take the course. So please go and grab it. Nothing to lose, a lot to gain. 30 days, money back guarantee. And if you want to get the course cheaper, simply go in my mailing list by downloading the complete project and all of the assets that I use in this tutorial series. Link is in the description below. So this was it in short about enumerations. Again, you can go and take a look at that in my other tutorials, the C# section playlist regarding only C#, where we don't create games, and you will learn what are enums. So what are the variables that we need now? Well, we need a private animator, which is anim. And by the way, let me just check if Unity added automatically the animator to the walk-in. Yes, we did, but we don't have the animator controller. As you can see here, he is located into the models, and here he is. This is the animator controller. So select the Vulkan, not the robot parent, but the Vulkan game object. Selected, he has an animator component attached on him. So drag and drop the Vulkan controller here into the empty field. You can also click on this little circle and then search it right here in this pop-up window, and then we're good to go. Let me quickly hit apply so that the change applies to the prefab. So we need the animator component. We also need a private audio source, which I'm gonna call audio manager. And we also need a private direction dir, which is equal to direction left by default, or actually direction right by default. Because by default, we are moving to the right, well, side. We also need a public game object missile, which is the missiles that we are firing from the robot, as you saw into the preview of the, well, this tutorial series. We also need a reference to all of the particle systems. When I say all of the particle systems, I mean this muzzle here, and I also mean the fire, which is, well, also here. You see the fire? See it firing here? So yeah, that's also a particle system that we need. So if you select both of these, and when we talked about particle systems, I told you that you can go and take a look at the video from the My Guide dude, or however his name is, and he explains in depth what every single option into the particle system is doing. And then you can simply go here where I create some awesome particle effects and take a look at how they are created. So we need a public particle system. So we need a right muzzle. We also need, let me just type it here, left muzzle. We also need a right fire, left fire, and we need a boost. The boost is this dude right here. So did we attach the boost? Actually, we did not attach the boost. So it is a good idea to also go and attach the boost, but we need to import it. So right click, import package, custom package, and this is the boost, this right here. Double click it and open it and click import. And if I go into the prefabs, this is the boost. You see, this is the boost, which is actually the, like, you know, we have a rocket and the rocket is going up, you know, the backwards on the robot. We saw that in the preview anyways. I'm simply gonna drag and drop it here as a child of the robot, and I am gonna set the position 0, 0, 0, but actually now I'm gonna take it and I am gonna put it right here. So this is the boost. This is what I was talking about. If I click to simulate, notice, you see the boost now? Yeah, this is that boost. So when he is flying, we're gonna simulate this boost. Select the robot and hit apply so that the change applies to the prefab. Again, you're gonna right click, import package, a custom one, and here it is, boost. It is located here into the folder I gave you. The folder, it's into the packages, boost, cannon, level, whatnot. We imported a couple of these, so now we are importing the boost. So you have it. Don't go on me, oh, I cannot find it, I don't know where it is. It's located into the assets that you need to download. Okay? Okay, you understand me. So moving forward, we also need a public transform, which is the left arm and the right arm, because we need to rotate or be able to rotate the arms. And we also need a public transform, which is a missile point. This is the point from which we are gonna start spawning the missiles. We did not create it, so we are gonna go here in Unity. Select the robot, right click and create an empty game object, and I'm gonna call this one missile point. And I'm gonna position it here. So yeah, this is okay, I think. Precisely, this is what we need, maybe a little bit backwards, but essentially this is what I want. So here is the missile point. Again, select the robot, hit apply so that the change applies to the prefab. Any change you make to the game object that is here into the hierarchy or in the scene and you have a prefab, make sure that you hit apply at the bottom right, or actually top right corner here into the inspector, hit apply so that the change applies to the prefab. Anyways, this is our missile point. Besides of that, we need a public float, or actually we also need a public light, which is gonna be left light and a right light, like this. We also need a public float speed, which is the movement of the robot, and a private float jump timer, which is equal to 0. So this is essentially what we need in order to manipulate what I just said, but we also need a rigid body. We also need to be able to edit the emission rate of these particle systems. And in order to edit the emission rate, we need to create a private particle system .main module. And this is gonna be right underscore muzzle underscore emission. And it's gonna be also for the left one. So copy the name and paste it here. This is gonna be left. Actually, let me just go back here and only change this, so left. And we are also gonna have the one for the fire, so right fire, not muzzle, change it to fire. And I'm also gonna have a left fire, so here is left fire emission, and voila, we're good to go. And we need one for the boost, so I'm gonna take this here, let me just copy it from here, or actually I'm simply gonna say here common, I'm gonna say boost main, and we are good to go. And we need a private rigid body, my body as always, and a private constant force, which is const force. This is a reference, so constant force is a reference to this that we applied. So select the robot, not the Vulcan. Here it is, this constant force component, because we need a reference to it when we want to make our game object fly like a little birdie. And now I'm going to change the void start to awake. So I'm going to change it into awake. And here we are going to say anim is equal to get component in children, which is going to be animator, not anim, animator, animator, or how I want to call it. I think I talked about get component in children in our Infinite Cat Runner Jump game, and I just butchered the name, Jumpy Cat, whatever I named the game. So get component in children. Why is that? Because this script, this player script, it is attached on the robot, which is the parent game object. As you can see in the inspector, when we select the robot, it does not have the animator component attached on it. Nowhere to see the animator component. And the animator component is attached into the Vulcan, which is a child of the robot. So if you want to get the component in children, you simply type get component in children. This is programming, it's all logic. So if you need a component that's in your child, get component in child, and voila, you're good to go. And we're gonna set anim play. Initially it's gonna play the walk animation. And what is that? Well, if we go here, select the Vulcan, go into the animator, and we have the walk. Notice this is the walk animation. We also have the idle one, which is simply sitting. So essentially we will play the walk, but don't worry, we will see all of that when we start our game. No biggie, we can even set it to play the idle. You will see it will have no effect. Audio manager is equal to get component. We're gonna get the audio source component. And for the my body, so my body is equal to get component rigid body. This is all basic stuff. We did it 1,000,000 of times. Yes, 1,000,000 times we did this. So it's simply getting the component that's attached on a game object. And notice now this constant force. As we can see, select the robot. Constant force is right here below the rigid body. So we should do something like this. We should do const force variable is equal to get component, and we should pass here constant force. But this is what you might think. We're gonna use it like this, my body dot get component. So the constant force is somewhat like attached on the rigid body. So in order to get it, use my body get component constant force, and you are good to go. So now we need to get all of the references to these right here, left muzzle, right muzzle, but they are public. So we need to go here and select the robot, and now we need to fill out things. The missile we still did not import. So we need to right click here into our project. So right click, import package, custom package, and here search for the missile. Here it is, missile. I'm gonna double click on it, and voila, click import. Actually, I'm gonna uncheck these to explode and missile. We don't need these because we imported them already, so don't worry. And I'm gonna click import, and voila, here it is, missile. Here it is. We have one script missing, which we are gonna attach, don't worry. And for the audio clip here, for the audio source, it's missing a clip. Click on the little circle and select this one, explode. This is the one that we need. Everything else, don't touch, don't worry, we will do that later on. Now select the robot and simply attach the missile here. We need the right muzzle, so here I'm gonna go into the right arm, and here we have, from the right arm we have the right muzzle, select it. We have the left muzzle from the left arm, so left muzzle. We also need the right fire, so it's under right arm muzzle and below it fire. We also need one for the left, so left fire. By the way, it's under right arm, so here it is, muzzle, and below it, so it has a child, which is fire. So simply select that, drag and drop it here. For the boost, I'm gonna simply put the boost here. Left arm, okay, here it is. Select the left arm and put it here. Right arm, select it and put it here. Missile point, okay. Select the missile point, put it here. Left, right, left, right. Left light and put it here. And right light and put it here. And we're good to go. Let me hit apply so that these changes apply to the prefab. And we don't need to do this every single time we import the game object into our scene. So now that we have the references to all of these variables, so we have the reference to these, and whatnot, what we need to do is we need to simply say right underscore muzzle emission is now equal to right muzzle dot emission. Now the reason for it is because now we are going to say right muzzle emission dot rate over time, so emission rate, right muzzle emission, why isn't it giving me? So right muzzle emission dot randomized direction. What did I type here? Particle system main module. And yeah, silly me, it's not main module here. I will copy this. Here it needs to be dot emission module. And main module is here, and we only have the boost main. So yeah, we need to put the boost main here. Sorry for this one. Emission module is here, and main module is here, and boost main is for that. So all of these variables here are actually for the emission module. Let me just see what is the problem here. Yeah. Anyways, now we can type here right muzzle emission dot, and now I can say rate over time is finally equal to 0. What this will do is, well, it will stop these particles from firing. You see, when we start our game, let me just demonstrate that. So I'm gonna copy or uncomment this line of code, and actually I'm gonna take left muzzle, so left underscore muzzle emission is equal to left muzzle dot emission. And I'm going to do the same thing here. Copy this, uncomment it, copy it, paste it here. And now we have the left muzzle emission. And notice what this is going to do. I'm going to first comment these lines of code out. When we first run our game, and let me just see where the camera is pointing. It is pointing at our robot. So when we first run our game, notice the particles are just shooting. The particles are shooting like crazy. We do not want that. And for that, we're simply going to do this. So we're going to set the rate over time to 0. And if I run the game now, we should not see the particles firing. We see this fire effect though, but we don't see the particles coming out of that effect. Coming out. So we don't see the particles, okay? Anyways, this is what rate over time does. We're also going to have right fire, actually this one, right fire emission is equal to right fire dot emission. We're gonna do the same thing with the left one. So here we are gonna have the left fire emission is equal to the left fire dot emission. Now the reason why we're doing it like this is that we cannot edit the emission directly. We cannot say this. We cannot type left fire emission dot rate over time is equal to 0f. Notice what we are gonna get into the console. It says cannot modify a value type, return a value, blah blah blah. It's not, well, it does not allow us to do it like this. We need to store it in a variable first. Same as why we cannot do transform.position.x is equal to, for example, 4f. We cannot do this. If we go back here, notice we are going to have an error. Let me just see here. It says transform.position. We cannot modify the value. Consider storing the value in a temporary variable. So what we need to do is we need to do this. We need to say vector3 temp is equal to transform.position. And now we say temp.x is equal to 4f. And now we say transform.position is equal to temp. This is the same concept. We cannot edit this directly. Instead, we need to store it here. And from here, we are going to edit it. So now I can say here, right fire emission dot rate over time is equal to 0f, and the same thing for the left one. So here I'm going to say left fire emission rate over time is equal to, well, 0. So now we will not even see the fire. So if I try to run the game now, the fire that we previously saw, we're all not gonna see it. Notice we don't see it. And by the way, this reference script missing amount behavior is that these boxes here had one script, but we don't need it. So simply select all of them and remove components. So remove the script from them. And just to double check if the wall or some of these others have a script. Yeah, the block has one. So simply remove it because we do not need it. We can live without it. Anyways, this is for, well, setting up the game when we initially, well, run it. We are now gonna code the movement for our player, but for that we need a couple of functions. The first one is gonna be bool is grounded. This one is gonna tell us if the robot is standing on the ground, because if he is not flying, so the robot is not flying, and here we're gonna simply say return physics.raycast, and we're gonna raycast from position, transform that position, plus transform.forward multiplied by 0.4 f, and we're gonna plus to it, so add to it transform.up, multiplied by 0.1 f, and in the direction vector 3 down, and the distance is gonna be 0.1 f. What did we just do? So this ray cast, and I talked about it, it is gonna cast, it is gonna create a line from position, in direction, and the length. This is that from position. So from position, our own transform plus transform forward multiplied by 0.4 and transform up multiplied by 0.1. So essentially we are gonna raycast up multiplied by 0.1 and forward 0.4. So multiplied by 0.4. In the direction vector 3 down, and this is the distance. So essentially if I grab my highlight tool, this is the initial position from which we are gonna cast. So let's say that position is here, and we are gonna cast vector 3 down, meaning down, and one is also gonna be like this. So we have one position forward, and one is gonna be down, and the distance is gonna be 1 point or 0.1. So this right here is 0.1, and this right here is also 0.1. If this little line here hits a ground, which in our case it will do because we are standing on the ground, it will tell us that we are standing on the ground. So this is what we are essentially doing. Because again, if I go here, notice where the robot is. He is standing on the ground. So he is standing here. The raycast will go down. It will hit this block, and we will know that we are on the ground. Simple as that. So we need this one is grounded. We also need void turn left, and inside of this one we are simply going to say transform that position is equal to new vector 3, and here we're going to say transform that position dot x, so dot x, and transform that position dot y, and 0 for the z, and here we're going to say dir is now equal to direction left, and we're going to copy this. And we are simply going to say here, turn right. Turn right, and we're going to do the same thing, except here we are going to turn right. Now, this will be clear when we start coding the movement now, but essentially just type it out. And when we go into the fixed update now, so this is not going to be update, but it is going to be fixed update. Here is where we are going to move our player. So what we can do is we can test if input dot get key. So if the inputted key is key code left arrow like this, or if the input dot get key is equal to key code A, because we want to move left or right. So if we press the left arrow key on our keyboard, or if we press the A key on our keyboard, we are moving to the left side. And here we need to test if the lean tween dot is tweening, and we are going to say here game object. What does this mean? And we're also going to type here an exclamation mark. So if we type here lean tween dot is tweening, notice the explanation says test whether or not a tween is active on a game object. This lean tween, we talked about it into our infinite cat jumper, jumpy cat. It is essentially moving the game object left and right, and during that movement, the game object is tweening. So we are checking if the game object is not tweening at the moment. So we are not using lean tween on it. Notice the exclamation mark. If this right here returns false, the exclamation mark will make it the opposite, which is true. So we are essentially testing if the game object is not being tweened, meaning the lean tween plugin is not being used on that game object. If that is true, let us test if the game object is grounded. So is grounded. If it's grounded, we are gonna call the anim to play the, well, idle animation, or actually walk. So here we're gonna say walk. Else, if it's not grounded, we're gonna call the anim to play the idle animation. Why that? Well, if we are in the air, we are gonna play the idle animation, not the walk animation. And by the way, I talked about this. If we only have one statement after the if statement, so if this is true and we only have one line of code to execute, we can omit the curly bracket. So we can also use it like this. So I can use it like this here. So I can type it here, and I can also type it like this. This can also work. It's totally legit. But we only have one line here, so we can omit these curly brackets. I can remove these like this, and I can also remove them here. And this is totally legit. This is how programmers program. You will use this in your own development. If somebody hires you, you will also use this. So it is a good thing to know, because maybe you will be presented with some code and you see this and you're like, oh, what the hell is this? Well, it's totally fine to omit curly brackets if you only have one. This only goes for one line. If you have more than one, if we have after this one more code, this will not work. We will need to have curly brackets. Anyways, if the player is grounded, play the walk animation. And this is if he is moving. So if we press the left arrow key or the A key and the object is not being tweened, so the lean tween is not being used on him. If he is grounded, play the walk animation because we are moving. If he is in the air, play the idle animation. And here I'm gonna say if direction is not equal to direction left. So if the direction variable here, this one, direction, dir, if it's not equal to the left direction, then we're gonna say lean tween dot rotate around local, and we're gonna rotate the game object. We're gonna rotate it on the y-axis, and we're gonna rotate it 180 degrees in 0.3 of a second. And then what we are gonna do? Then we are gonna say set on complete, and here I'm simply gonna pass turn left. And what does this mean? What is this, teacher? Are you crazy? Well, maybe a little, but it has nothing to do with this here. Lean tween, we talked about it in our Infinite Cat or Jumpy Cat game. This is a plugin that we can use to create some awesome effects, such as rotate around local. And this rotate around local, and local is his own axis in respect to his own position, not respect to the world position. And we're gonna rotate the current game object, which is this one. So this one right here, the robot, this game object, he's gonna be rotated, and he's gonna be rotated on the y-axis. Why y-axis? Well, if I type here vector3.up, notice here, it says shorthand for writing 0, 1, 0. And this is the y-axis. So rotate him on the y-axis. How much? Rotate him 180 degrees. For how long? In 0.3 of a second. So in 0.3 second, rotate the game object on the y-axis for 180 degrees. When that finishes, so when you rotate that game object this many degrees in this many seconds, call the function here. So set on complete, call the function turn left. What does that mean? We are gonna reset the position to the current position, and we are then simply gonna say direction left is equal to the direction left, because now we are moving to the left side. Else, not effector, selector, else, again. Why are you, else, finally. Else, if the direction is equal to direction left, then we're simply gonna say transform.translate, which means move the game object, and we're gonna say vector3 forward multiplied by speed multiplied by time dot delta time. What is vector 3 or vector trans, or actually transform translate? So transform.translate. It says moves the transform in the direction and distance of translation. So it will move the game object. So this translate will move this transform, which is, well, our player's transform. It will move it into forward direction, and we're going to multiply that by speed and multiply it by time dot delta time. And that is that. Else if, but we need to first select this one right here. So here we need to type else if, and I'm going to copy all of this here. So else if input is equal to right arrow, or the D key. What we want to do, well, we want to do all of this, but into the separate direction. So we can safely copy all of this here. So I can copy all of this here because we are going to check if the game object is not currently tweening. If we are on the ground, we will play the walk animation. If we are in the air, we will play the idle animation. If the direction is not equal to direction right here, then we are going to rotate our game object to the negative 180 degrees. And here we are going to say turn right. So turn right instead of left. Turn right. Else here we're going to say transform. Everything is going to be the same. So everything is going to be the same. And let me just go here. Actually, yeah, here. And we need to type else. We're simply going to call the anim to play the idle animation. This is what I meant when I said that here it will not matter, because when we are in the fixed update, if we are not pressing left arrow key or A key or right arrow key or D key, we will play the idle animation. So we can safely also remove this from here, just so that I don't confuse you. Anyways, so just so that I don't confuse you, we can remove it from here. And this is it for the moving of our player. We can now test it out, and I will break down the code again. So if I try to run the game now, notice the player, if I hit right, he is moving right. If I hit left, notice how he's gonna rotate, and he is moving left. Again, rotating and moving right. Rotate, rotate, rotate. And he is moving. Do you see that? So do you see? He is moving. And how does that work? What is the point here? How does it work? And by the way, we're also going to take these point lights. So notice the point lights, right and left light, set the intensity to 0. Because when we shoot, we're going to pump up the intensity. At the moment, we are not shooting, so we are not going to pump up the intensity. So again, let's break down the code, what we did. All of this here is clear. We're simply getting the animator, audio source, setting the direction, which is the enum. This one right here. Here we are getting the particle system. We have attached all of that. I've explained what it is. We also actually don't need jump timer, so this is not important. Public float speed. This is for the movement. Particle system emission module. I've explained what it is, so we cannot edit it. And by the way, did I set here, so boost main is equal to boost, not bool, but boost dot main. So this is what we need here. So the main module here, particle system main module, we have the boost. So boost.main, we need to store it into boost main, which is the main module. So we stored all of that here inside of our awake. So we got the right muzzle emission from here, so on and so forth. Everything here is clear. This here is clear. So what we are doing here. First of all, here we are raycasting. Now I've explained what it is. So we are raycasting, drawing a line in this or from this position. So we are drawing a line from this position in this direction, and this is the length of that line. If that line hits a collider, which in this case it will do, it will hit this brick right here. It will hit it because we are standing on it. It will hit the brick and it will tell us that we are grounded, because this here returns a Boolean. If it hits a collider, it will return true. If not, it will return false. And turn left and turn right is simply setting the direction and setting the current position. So now we are going into the fixed update. We are checking if we are touching the left arrow or the A key. Here we are checking if we are touching the right arrow or the D key. This is for moving left and right, which is pretty clear. Then we are using this lean tween. This is a plugin. We talked about it in our Jumpy Cat. And essentially here we are testing if the lean tween is not acting upon the game object. So if we are not tweening the game object, if we are on the ground, which we are testing here, play the walk animation. If we are not on the ground, but we are pressing, so if we are not on the ground, but we are pressing these keys, meaning we are in the sky, we are flying. Currently, we did not program that, but we will later on. So if we are flying, play the idle animation, not the walk animation. If the direction is not equal to the left, because currently we are moving to the left direction. If the direction variable is not equal to left, rotate the game object. And we saw the rotation. Notice now, if I hit the play button, if I hit the A key, notice he is rotating because the direction was not equal to left. He simply rotated rotated a game object on the y-axis, and I've explained why, because vector 3 up is equal to new vector 3, 0 for the x, 1 for the y, 0 for the z. So this is vector 3. Essentially, this is y-axis. Rotated by 180 degrees for 0.3 of a second. After we finish the rotation, call turn left, which is this one right here. It will simply set the current position and it will change the direction. Simple as that. If the direction is set to direction left, simply move the game object into that direction. So we are currently facing the direction left. Move the game object in that direction by using translate, which will move the transform by using vector 3 forward. And notice here, if I type vector 3 forward, it says shorthand for writing vector 3 0.001. So it is moving on the z-axis. So move it on the z-axis. And we are simply using vector 3 forward multiplied by speed multiplied by delta time. If we are moving to the right side by pressing the right key or the D key, if we are not tweening, so if the tween is not acting upon the game object, if we are on the ground, play the walk animation. If we are in the sky, play the idle. If the direction is not equal to the right direction, rotate the game object by negative 180 degrees. So rotate him to the right side. After you complete the rotation, call here turn right function. The set on complete will simply call the function you specify here. So I specify turn right. So call that function, which will simply set the current position and it will change the direction. If, however, direction is set to the right direction, simply move the game object into that direction and we are good to go. If none of the above is true, play the idle animation because our player is not moving. One more time to test it out. If I hit the run button, moving left or moving left now, moving right, and notice every time we change direction, the robot is rotating and he is then moving. So this is what we, achieved in this video. I know it was pretty long, but I like to explain things in depth. I don't like to left anything unclear. I go above any other tutor on the internet as much as or as far as explanation is concerned, because I did not find anybody, literally anybody, who explains programming and game development as much as I do. My videos are like 40 minutes long. This one is probably 40 minutes long. I don't care. If you want to watch it, it's your benefit. I'm explaining things to you that nobody else wants to explain. Anyways, I'm gonna stop now. Go here, buy the course, support the tutorials, learn something useful. It will benefit you for sure. This is what you need. And if you wanna download the assets, link is in the description below. I'm Fahir from AwesomeTuts.com and I will see you in the next video.